So today we're going to be going over sine and cosine waves. Now these are two basic trig functions that we've seen how they're created simply by the relationship between two different sides in relation to the hypotenuse or the radius of a triangle or of the unit circle. We're going to see how they move around on the graph in relation to any sort of transformations, translations, dilations. And we're going to see that a lot of the language is very similar to what we've seen prior. Transformations or translations of sines and cosine waves work in the same way that translations and transformations of a cubic or a quadratic or a linear graph work. So let's review a few of the things. The terminology is slightly different. So with a sine wave, A isn't considered the stretch or compression, it's considered the amplitude. But it does stretch or compress the graph. It stretches or compresses the wave. A is the height from the midline, so the graph has a middle line where it goes above and below. And the bigger the A value, the more that graph goes above and below the line. The smaller the A, the less it wiggles. B is considered a horizontal stretch or compress. In this case, it reflects the period, or how long until the wave repeats itself. The H and the K, I don't know why I almost called the H X. The H and the K refer to the left and right movement and the up and down movement. It's the same on sine versus cosine. The only difference is our starting graph. So we notice translations are no different. Period, we've seen that, maybe not in that terminology before. Amplitude, we've seen that, maybe not in that terminology before. But the starting point, the only difference is the starting point is going to be the cosine starts at a peak and the sine starts at the actual midline. We got to remember this from where we created the graphs in videos prior. So let's take a look at number one. So number one, we're going to graph these trig functions, and we're just going to see what they would look like. So the sine function is going to be our parent function. What we know is that we're going to have a 2 pi repeat, which means the sine function is going to go up, down, and up by the time it hits 2 pi. The height that it goes up to is a height of 1, and it goes down to -1. Now, this is our base sine function. When we graph our sine wave, which happens to be our base sine function, we're going to move this graph around and then just keep it going. So with this graph, we're going to trace our original sine function. We're going to keep going, but it doesn't just go in one direction, it goes in the other. So it's going to continue to go down and up and down onwards. Now, how far back does it go? Well, it goes back. Remember, the period is how long it takes to repeat itself. So I'm going to say, okay, how long until it's going down through the x-axis? Right here. So this is going to be our -2 pi. And there we go. If you wanted to label a few of the points, we'd say, okay, start at midline. We would say, okay, the amplitude here is the height from the midline. The amplitude is going to be an amplitude of 1, because I noticed there's no number in front of it. The period is going to be 2 pi divided by the b. Well, I don't see a b, so that's why I know my period is automatically 2 pi. There's no shifts, there's no translations. None of that's going on. That is our parent sine function. So you can try the parent cosine function, but for the next one, what we're going to do is we're going to move this around just a little bit. We know this is a sine wave, so it's going to start at the midline, We know the amplitude is going to be how far up or down the sine wave goes. This amplitude is going to be 2. So it's going to go up 2 and down 2, up 2 and down 2. We notice the period, we said, is going to be 2 pi divided by b, and in this case, I do have a b. So my period is going to be 2 pi divided by, let's do our b in red, of pi. So the pi's are going to cancel out. Our period is 2. So instead of being 2 pi, we know this sine is going to start at the midline. There's no movement first off. So let's go ahead and draw our original sine wave. And this is at 2 pi. Now, 2 pi is roughly 6.28. So this repeated itself about every 6.2 units. If our new sine wave is going to repeat itself every 2 units, it's going to have a much tighter period. So let's see, out of 6.28, let's call this 6. So that would mean that this is roughly 4, and this is roughly 2. So this whole sine wave is going to repeat itself from here to here. This whole thing is literally just going to be squished inwards. The amplitude is going to go up instead of up 1 and down 1. This amplitude is going to go up 2 and down 2. So not only does it repeat itself all the way within this range, but it's going to go up further and down further. Let's go ahead and crank that thing all the way up, all the way down, and all the way up. That is our new sine wave. We've squished it and we've stretched it. Now, realistically, what we'd want to do is we'd want to continue this sine wave onwards. So I'm going to continue this. This is our new sine wave. I'm going to continue this in a different color, so that way we can see down, up. It repeats itself. That's the same wave again, even though it looks a little bigger. That's just due to the error of my drawing. Up, down, up. In fact, every 2 units, it goes up, it goes down, and it goes up. Same going backwards. It's going to go down, up, and down. So that must mean that's -2. It's going to go down, up, and down. That must mean -6, or -4. Down, up, down. So it continues on, but we see that the original graph has been squished and stretched. So this is a rough sketch. Let's try and do a little better on the next one. We're not going to graph the parent graph anymore now that we kind of see what's going on. And let's graph a few of the hot points. And the hot points that we want to graph, kind of like on number 3, we just drew our sketch. We want to draw our halfway marker, which means we're going to label this as pi, so half of my period. And I want to label both the peak and the trough. So I want to label where is that top point at and where is that low point at. In this case, half of pi is just pi halves. In this case, halfway between this is 3 pi over 2. So really that's all we need. We need the period, the intercept or the halfway point. I need the peak and the trough. And with that information, I can pretty much graph anything. Now I'm not going to label this right here because there's too much going on, but for number 5, I can. So let's take a look at the sine wave. So I know this is going to start at the midline. I also know this. There's been a couple things happening here. The amplitude is 1. It hasn't been stretched like this. It's still going to go up 1 and down 1, but the period has changed. And in this case, the period is not going to be 2 pi divided by 2, as you would like to think, because we notice that I have to have an x minus h. So I'm going to have to factor something out of both the x and the h, or this term and this term, to pull something out. So I'm going to look at 2 and 4, and I want to pull everything out of the x. So it's going to turn into sine of 2, x minus 2. So there's my equation. Now, sine of 2, parentheses x minus 2, plus 2, we notice the period, I guess I said this improperly, is going to be 2 pi divided by 2. It will affect the movement to the left and to the right. So 2 pi divided by 2, that means my period is going to be every pi units. So I know that this graph is going to repeat itself every pi units. I do know that the graph is going to, in this case, have been moved to the right 2 and up 2. So I'm going to see my graph start right 2 and up 2. So let's go ahead and let's define a few things. If I know I'm moving right 2, there's my 2 and my 2. This is going to be the starting point of my graph. So let's trace this over in red. I know the amplitude is going to go up 1 and down 1 from that point. So I'm going to need to label a few things here. Up 1 from 2 is going to be 3, and down 1 is going to be 1. I know that the graph is going to stay basically within that range right there. Sketch the boundaries to where we know where the graph is going to fall. So what they'll do is they'll draw in pencil something that they're going to erase. I know that my graph is going to stay within those two lines, and I know that all of this is eventually going to be erased. So none of this is going to matter. My graph is going to stay within those two realms. Okay. So I moved it right and up. I know the amplitude and I know the period. The period is going to be pi units from that point. So now this is, I guess you would say, the tricky part, because I need to go pi units away from 2. So I'm going to do a rough approximation. So 2 plus pi, that's going to be 2 plus around 3.14. That's going to be around the 5 marker. So if I go 2, let's say this will be 4, and this would be 6, which means around right here-ish is going to be my 2 plus pi, which is where the graph is going to end up having repeated itself. And so without labeling any other points, I know what the graph is going to look like. It's a sine wave. It's going to start at the midline. It's going to go up. It's going to go down. And it's going to go up, staying literally within those boundaries. And it's going to repeat itself after that. So it's going to keep going up and down and up. In fact, the same thing is going to happen backwards. And without actually figuring out where this is going to go on this, go down, up. And you see the fact that this sine wave is just bouncing back and forth between these two barriers that we drew. But again, we want to label a couple things. I want to label where the period ends, which is 2 plus pi. I want to label the middle part, and I want to label the peak and the trough. So we're going to go ahead and we're going to get a little closer here. I know the midpoint is going to be halfway between 2 and 2 plus pi. So we're going to say 2 plus pi over 2, which in this case, as I zoomed in, 2 plus pi over 2 is going to give us roughly 3.5. So I know roughly at, let's see, that's 2, that's 4, so around 3.5. Ooh, perfect. This is going to be 2 plus pi over 2. And then my last 2 points is I need to label that part and that part. So I'm going to come down here because this is a very tight graph. Didn't necessarily think about this when I made this sheet. I need to label where the peak is and where the trough is. So if that's 2 plus pi over 2 is going to get me that intercept point, which was an intercept previously, I need to cut that in half again. So not pi over 2, but pi over 4. So 2 plus pi over 4. And if that's 1, 2, this will be 3 pi over 4. So this will be 2 plus 3 pi over 4. That way I have a nice set of 4 points. I have my first, second, third, fourth point. Or I guess you would say first point away, second, third, and fourth point away. And that's that. So that was a little exciting because we had to translate both in units of pi and in whole units. That's not typically how the problems are going to be set up. So what I want you to try is I want you to try number 7. This is going to be all in units of pi, so it's going to be a little easier to find your numbers. Pause the video, unpause it when you're done, and see how well you did. Okay, so let's take a look and see what we're working with here. So I noticed that I have something in front of x, so I'm immediately going to go ahead and rewrite this function, pulling out that pi. So pull out a pi, I'm left with x minus 2. So in this case, what we're going to do is I'm going to say, hey, I know that this starts at a peak. However, Because of the negative sign, that peak is going to be a trough or a valley. Because of the negative sign. It's not going to start at the top, it's going to start at the bottom. We know the period is going to be 2 pi divided by b. In this case, my b is going to be pi. So my period is 2 units long. I know the amplitude is going to be whatever that is, so it's going to be -1. Now, an amplitude of -1 doesn't mean it doesn't go up 1 and down 1. It just means it goes down 1 and up 1. It reverses. Instead of going up, it's going down. We also know this has been moved to the right by 2 units. So let's go ahead and set where our starting point is. I know it's moved to the right 2 units. So at 2, I'm going to pop my first point right there. And I know at 2 units, it also repeats itself every 2 units. So 2 and at 4, this thing is going to repeat itself. Okay. Also, I know the fact that with a sine wave, it's going to start not at the midline like a cosine would, where we're going to use those points. What we're going to do is we're going to say, hey, let's start at the trough. Instead of starting at the wave and moving up and down from here, let's assume this is the midline of the wave. And let's go ahead and do cosine in green. Give ourselves a little room to work with. Let's call that 1. Let's call that -1. That's the midline of the function. I'm going to start this one at a trough. So at -1, I'm going to start my cosine function. And then what I'm going to do is I'm going to end at -1, which means that this graph has to curve all the way up until it hits the value of 1, and then back down. And so what we'll see like a sine wave, it starts at mid and ends at mid. This looks a little funky until we finish out the rest of the graph. Let's see, so if it hits peak, trough every 1, so it means that this will be at a peak, trough, and then it would be at a peak, trough, peak, trough. You see they look almost identical. It's just where we start and where we stop. So now that we've gotten that, we just need to label our points. We already have our start and our stop point, which means that we already have our middle point right here labeled. I know that my minimum and my maximum are going to happen at 2, 4, and then at 3. All we need is we need to figure out what these middle points are. And because I've already used purple, green, and red, let's use blue to label these points. We're going to call these points the points of inflection. We're going to find out more about them later on. Halfway between 2 and 3, I have 2.5. Halfway between 3 and 4, I have 3.5. There we go. We have all points on a cosine graph labeled.